Hello everyone. Hello, welcome. Welcome to our webinar. I'm very glad to see you all here to hear a little bit more about the 3D digitalization of national heritage resources. For everyone who doesn't know me yet, I'm Natalia Skornicka. I'm archaeologist and I work here at SMARTTECH as a 3D scanning specialist for science and research applications, actually. So very much in the subject. And here with me is our senior engineer, Paweł Aksamit. He will be helping me and presenting you the abilities of a structured light technology today. So let's jump straight into the presentation. I would like to start with a few words about the company that we are here today, but I will not be focusing only on the technology that is here invented and developed in this company. I would like to give you a little bit more knowledge and information about the archaeology and about different 3D scanning technologies that are possible to be implemented in the field. This webinar has two main reasons why we decided to give such a lecture, such a short lecture. First of all, as SMARTTECH itself grows from the universities, it's very, very important for us here to educate people and to give a head of what's new in technology. We also have a lot of questions from archaeologists since a few years, and the lead cause of that is that the European Union gave a recommendation in 2019 for our museums in Europe to digitize at least 50% of the collection that they have. And since then, we observe growth interest from the archaeological field. What this 3D scanning and 3D technology actually is. Also, we catching this wave of interest, we developed our devices that we offer, especially for that field of archaeology, that we will be presenting today. But going back to the company, just a few words. We are a company from Poland, from Warsaw, so the capital, and here in the house we develop our own technology. We build our hardware and our software. The company was opened over 20 years ago, so we have quite of an experience already, as you can see on the history chart, and the technology is basically recognized from the very, very beginning, getting a lot of awards for both hardware and the software. A few of the customers that we've worked through that time. So just to name a few on the screen, but of course the list is much, much longer. A lot of museums and institutes trust us and recognize the quality of the technology that we are using, basically because we are focusing, especially in my department of working with archaeology and museums, to develop the device that will be dedicated, easy to use, that will be straight away response for the need of the archaeological market. But to start, what exactly is a 3D scanning for all of those who are from the field and are interested and just start your adventure with a 3D scanning? 3D scan is basically changing the image or making an image of a real object and taking it to its digital form. So you can use it on your computer, on your laptop, on your phones. We have different methods of 3D scanning, which I will be describing in a moment. But when we are talking about about 3D scanning, we will be using few terms: visualization, digitalization, and archiving. And I think it's very important to know the difference between them. So starting from visualization, it's basically the most basic form, the most basic form of the 3D image that we can see on the screen. So the density of the image is a little bit lower. The density of points, let's say, is a little bit lower. So the data file is lighter, also easier to implement in your presentation or on your website. And you have good image of what the object is, but you don't have any data about metrology, so you cannot measure it. So those data are great to use on your website, but you cannot base any research on it. The step up from the visualization is digitalization. So adding to very good representation of the surface of the object, we are adding also a metrical data. So we will know the size of an object, the distance between points that we want to measure. Those data can be used for research, are very good representation of the object, can be a part of documentation, of professional archaeological documentation. And up from there, we have archival data. Those are data that have to be unprocessed. So they are raw data from scanning, and they can be added for the archival process of documentation for museums. And the scanners, not all of the scanners can be used for all of those methods, but scanners that we are using here at SMARTTECH that are dedicated for use in museums are perfect for also archival purposes. You will see on the technical presentation part how clean are the raw data also, so you can see also on the archival level exactly what object you've scanned. Why we are actually scanning? Why it's important to implement that technology to wide use, to popular use in archaeology. From my point of view, it's a great addition, and it can even be like upgraded documentation that we are using today. So of course archaeologists are using like photos and drawings and descriptions, etc., of objects that that we find or we describe, but the 3D model can give you all those information and more, with more precise data, more precise measuring, very, very fast. And because it's a machine that is capturing all those data, the element of someone's mistake, of person mistake, is minimal. So again, if we are drawing some cup or some pottery lip, and someone is putting it incorrectly on the page, we cannot be sure if that wasn't the case. And when we are using 3D scanner, we have an image. So we have very, very detailed data. And later that data can be used for many different purposes. We can use it for 3D printing. We can use it for education. We can put it online. So there's many, many possibilities. We can modify the model later on and try to make something new or revive the functionality of an object. So there are endless possibilities I will show you at the very end of the presentation. And going from that, from why are we scanning, we are jumping also very smoothly to advantages of using the 3D scanners. So first of all, the data that we are getting are very precise, especially if we are choosing a scanner that is that goes with certification. Like scanners here at SMARTTECH, they are going with like German standard certification of accuracy. We can be sure that data that we are capturing can be used for research. So that is a perfect amount of information that we can easily share. Also capturing that level of accuracy and that level of details, including colors and all the ornaments, etc., is very, very fast when we are using 3D scanner, incomparably faster than when we are using traditional methods popular today in archaeology. Also, when we have a 3D model, we can easily share it between users, between institutes, between countries. We don't have to travel now from institute to touch something. Of course, if we want, we can, but we don't have to now to build a very good paper, for example, to have a lot of comparison data, because we can just share it online. It opens many, many doors. The scanners are very easy to use. We here at SMARTTECH are very focused on making both our hardware and our software very user-friendly. A lot of our customers are not from technical background, and you will see also on the technical presentation that the software is easy. The hardware is basically you plug in and start to scan. So very, very convenient and easy to use device that gives you very high quality data. When we are talking about 3D scanners, we are using a few basic technical terms that I will be mentioning also during my presentation. First is a resolution, and the second is accuracy. I will also show the difference on the second picture in a moment, but basically, the resolution is the number of points that we have. Let's say the image is a point cloud. You will see it also in our technology. So we have on the given area, on the millimeter square, a certain amount of points. That's the resolution of the scanners or the image. And then we have accuracy that gives you information about the maximal mistake of placement of each point according to the same point and the real object. So this is something also very, very important, known and given with the structured light scanners. We also have data about color mapping, so and format of final data is also important when we are talking about 3D scanning, simply because if we or something that it's important to know, because we can use the data after post-processing to many different applications. We can 3D print it, we can share it, etc. So it's good to know the format of the final data, of course. And here on the screen, you have a comparison why the resolution is important and the difference between resolution and accuracy, actually, you have here. Both pictures that you can see currently on the screen have the same resolution, the same accuracy, which means each point on both pictures have the same mistake of placement. But the resolution of the left one is lower than the resolution of the right one. And you can see that even if the accuracy is exactly the same, the visibility of details on the higher resolution picture is obviously much, much better. So this is those are two parameters are very important to ask when you are choosing your 3D scanner. We are going to the main core of the presentation, so different 3D scanning methods. As I mentioned at the very beginning, we will not be focusing only on the structured light scanners. We want you and archaeological community to know what you can choose from actually when you are searching for scanners for your projects. We can have two main digitalization methods, passive and active. Passive methods are basically those that do not project any kind of light directly to the object when capturing data. Here, within that passive group, we have let's say two main recognizable methods, photogrammetry and structure from motion. Photogrammetry is, I would say, the most popular among archaeologists currently. This is the method that enables to have a 3D model with the use of photos. You need at least two photos, they say, but actually you are using a lot of photos, as you can see currently on the video, and then you stitch them together using some known points that have their position on the meteorological system, so in the XYZ coordinate. That method allows you to have a very good quality image, so you have very good texture quality, and you are not restricted by any but by the size of the object. So it doesn't matter how big or how small the object is, you can get good quality, good looking texture of an object, good looking image. Also, the pros is that the cost of this method is relatively small. You basically need just a good quality camera and of course the software. But going to the software, it's not that easy to operate. You need to have some extensive training. It's not so intuitive. It's easy to make mistakes with it. So you need some training to operate the software. Also, I mentioned that those pictures are stitched by known points, and only those points have determined coordinates, which means you can measure the object only by those points. The rest of the object is only more or less accurate according to that point, to those points. So we cannot say that photogrammetry is giving us a meteorological 3D model. The second method is structure from motion. This is the method that also based on the photos, but here we do not have any relation with the coordinate system. So we have a very good, good quality object again, good quality texture. We are not restricted by the size of the object, the same as with the photogrammetry as well. And again, the cost of the a device is relatively small, let's say, in comparison to active methods. But we do not have any points that are placed in the coordinate system, so we cannot be sure, or we cannot know at all the real size of an object. And also, software that we are using for this method cannot verify itself if the model that was built is correct, so we have to do it manually. So going back to digitalization methods, we have also active methods. Those methods base on projecting light on the object or maybe the beam, projecting the beam on the object to register the geometry. Here, the most popular in my opinion, and are laser triangulation, time of flight, and structured light technology methods. So, laser triangulation method is using a laser beam projected on the object, and it's registering that laser to capture geometry. Here we have even geometry sampling on the whole object. So where the beam is, we have the even geometry, and we can use that method for measuring directly on the sunlight. So we are not restricted by any kind of lightning in this method. But also, as you can see on that very short video, the device itself has a pretty complicated structure, so it is easy to be damaged or easy to be recalibrated. That can be when measuring. Also, the time of registering data is pretty long, and out of all three methods all three active methods that I will be describing this one, if capturing color, because it's also not a standard option, it has the worst capabilities of capturing the quality color of all three. Then we have a time of flight method. This is also using a laser beam, but it registers the time of flight of that beam. It's also pretty popular in archaeology currently, and it's basically used for 3D scanning of bigger objects like buildings. Here also, again, as in previous method, we have 3D geometry, even 3D geometry sampling throughout the whole geometry. And we know the accuracy right from the start of the model that we will be getting. And we can measure on the sunlight again. So this is a pretty standard for measuring with a laser beam. But here we have also the device that is pretty sensible to recalibration. Whoever was working with a time of flight device on the excavation side, which are pretty popular. They know that the recalibration can be a problem. And also the accuracy of that method is not that high. So it's not recommended to use for smaller objects. When you want to scan a whole building, the low accuracy is not such a problem, because like 0.1 millimeter accuracy is enough for the whole building. But if we are scanning a cup of earring or the earring, then the misplacement of the point by that much will be a problem, and the quality of the model will be too low to use it for research. And we went for structured light technology. This is the newest of all three methods, and also the most advanced. This method is using structured light to capture data, so not laser this time. That makes it safe for the painted surfaces, for the eyesight. Also, devices doesn't radiate in any way, so you can the operator can work with it for a long period of time. We have again even geometry sampling through the whole object, so we know the position of each point. Also important is that when we are using structured light, the results of the scanning is a point cloud, which you will see on the technical presentation. And each of that millions of points has known position in the coordinate system. So the 3D model is completely measurable, and we also know the accuracy of the placement of each point. So perfect source for research. Here, what we are working on, especially at SMARTTECH, we want the scanners to be made with like the newest possible protection technologies also to make them resistant to recalibration and resistant to some damages. So you can, even if you want, use them while traveling. You can use them on excavation site, on some laboratory. So they have dust-proof filters. So they are pretty resistant to damage devices. But here we have a limitation of scanning on the direct sunlight. If we want to scan outside, it is recommended to use some kinds of tent, shading tent, or to scan inside. We can use like inside lighting easily, but direct sunlight will disturb the results of measuring. Also, the structured light technology is dedicated to scan smaller objects. Each scanner has something we call field of view, so the area that scanner can see with like single shot, let's say. And the best is if object fits in the field of view or it's few times bigger than the field of view. But if it's much bigger, then scanning that such object can be time consuming. So you can see on the screen a very fast summary of the methods that I mentioned. Important note is that there are no rules, given rules of which method and which device you should use for which work and which project. There are some recommendations. They started to appear from institutions and in some articles, but they are not. They are no like strict guidelines. So you need to base the technology that you are using on your knowledge or the knowledge of someone that you will ask about, ask for help. And that's why it's important to know what you can work with. And I would like to also say a little bit more about the technology that is available here and which I use on a daily basis that are available at SMARTTECH. So here the company is focusing on like creating two lines, I would say. One is dedicated for industrial application, and the second one is made especially for non-industrial applications, so archaeology, museology, also medicine, forensics, etc. So focusing only on those scanners that can be used in museums. Basically, we have two news to present today, because we received a lot of questions and a lot of requests from the archaeological community all over the world. We decided to focus. Since few years, we focus on those lines especially for that group, and we upgraded all of the scanners that are available for archaeology. And both you will be able to see today, and results from both will be presented. Even though the first one, one of them is like pro-premiere still, so a little sneak peek, especially for you, what you can expect to be launched very soon. But starting from the beginning, and something that is available since the beginning of this year, SMARTTECH3D On. So smaller scanner that it's easy to be handheld as a hand luggage for when you travel by plane or to move around. Smaller size casing, but the video is not going. But it is a stereo system scanner that has an ability to capture color. That's the use of stereo technology, so the use of two cameras in the scanner. enables to capture very well crisp, clean geometry, clean edges, crisp edges. So all the shapes are very, very well registered. And this scanner is very multi-use, I would say. So it is a point of interest for entry-level quality control and reverse engineering, which also can be applied for that level of detail for archaeology when you want, for example, compare two objects to each other, or you want to do some modifications for 3D printing, but also the scanner is a point of interest for education, for digitalization, entry-level digitalization, etc. Very interesting accessory for that scanner is a rotary tilting stage. This is something more maybe interesting for industry, but I wanted it to show it to you because for some applications it can be also interesting for archaeology. For example, to scanning coins with some when we will apply some magnetic mounting on it. So the rotary tilting stage is automated station that allows to scan 360 the object because it rotates as our regular rotary stages, and also it tilts to capture data all around. And a sneak peek for you, Micron 3D Color Stereo. Both scanners you can see on the second screen from the second camera on your screen. So this is the bigger one. That scanner is not available yet. It will be launched till at the end of this year, last quarter of this year, so very, very soon. But it will be like a very breaking news for the community, in my opinion. This is an upgraded Micron 3D Color. If you are familiar with SMARTTECH, you probably know that model that was very, very popular all around the world with museums and digitalization. But because digitalization is growing among archaeologists and customers from that industry also get more and more demanding, and projects are more demanding, we decided to upgrade it for stereo system also, and the resolution here go up to 20 megapixel for each camera, which makes the scanner the highest resolution available on the market. It will go also with the upgrade of a texturing module in our software, which also will be presented. I've seen the results. They are really breathtaking, so I cannot wait until you will see them also in a few minutes. SMARTTECH3D Measure, our software, I will not be describing it in details as the best way to learn is by seeing it in a moment, but important information is that scanner software is made here in the house, so any kind of customization is available if you need it. And also you can do the complete post-processing and measuring, some basic measuring, cross-sectioning in the software. Software is free with the scanner, so you don't have to, you will not be charged additionally for it. And also it works very smoothly and efficiently on like a standard laptop. You don't have to have a powerful dedicated workstation, which is also affecting the costs of the complete project. And just a few examples of our projects and what we were engaged with in terms of cooperation with museums and institutions all over the world. One of the most one of the most interesting projects is digitalization of the collection at the National Museum of Prehistory in Taiwan. They currently have 3 of our systems, and they are digitizing complete collection, which is available already online on their on their museum website, the part of it obviously, but you can see the results of scanning with our scanners. The museum also organizes some trainings and some educational series for students, etc. We have also similar projects in Poland, so some medieval artifacts you can see on the screen, which are also available online. Here, a similar project, but with additional flavor to it. In museum in Kalisz, also in Poland, we've done a digitalization of a coin. This is one of the first coin from Polish history, and it's very rare. Museum, besides having it digitized, they modified the scan that they achieved, and they created based on it a stamp to make copies, exact copies of that artifact, which is perfect for creating copies for another exhibitions, for educational purposes. You can send it to the university for students to have it in their hands and analyze it. Also, it is a pretty easy way and cheap way to make some very good looking objects for museum shops, for example. Another project of modifying 3D model we've done for Malbork Castle Museum, also in Poland. So we scanned a cannon to 3D print a copy to send it to the museum of the origin of this cannon, but also there was a project to digitally modify the model to bring back the functionality of the cannon. So very interesting project. One of the pride points in Poland, we have a biobank laboratory created online platform that has a digitized collection. For now, the project is pretty new, just a part of that collection of human remains from a particular part of Poland, and the data there is having also the metrical information, so you can use them for research. A few papers are already made based on it. They are available also on the website, so we can know a little bit more about the origin of the people, about diet, about migrations, a lot of very interesting information. Because data from our scanners are very detailed and metrical and certified, the devices are certified, we can build a research on the models, and also we can build a digital reconstruction that the missing part can be also 3D printed and be placed for the reconstruction, like in Institute of Archaeology, from the pictures you can see. And also we've done a reconstruction of the pottery plate, decorated plate that is, as you can see on the pictures, damaged. Normally archaeologists need to do the reconstruction manually, which takes time, and you need to know what you are doing. And here you can generate it automatically, and of course you have very detailed documentation. We've also scanned a collection of prehistorical I lost the word, like tools, flints, flint tools from Georgia. And first of all, you just take notice of the structure and the color of those flints, and all those little shapes all around. Who is working with prehistorical times knows they are very, very important. We've scanned it. It was sent to the museum, National Museum in Warsaw, and the museum organized a digitized exhibition of those collections. Interesting application also from Cardinal Stefan Wyszyński University, also from Warsaw. The car that you can see on the top left picture is a mobile digitizing center. They also have our scanner, and they can travel around and digitize objects. Here is one of the projects. The skull was of the remain calls the vampire from Piotrków. The vampire because of the nail that was pierced through the skull was scanned. It was placed on the rotary stage very carefully because it was very fragile. It was scanned, then 3D printed, and the results of it you can see on the bottom left, the right picture. This is not the original object. This is the 3D printing, the 3D printout of the skull that could be driven around for presentations safely. Scanners were also used for scanning the paintings. Here it was to check the differences or the damage that the humidity is doing for the structure of the painting. And as I mentioned, both scans could be compared to each other. On the top bottom right picture, you can see the results of comparison where the deformation appeared. And also the skull of a Peruvian woman was scanned. It is known all over the world as a Peruvian queen. The skull is over 1,200 years old. And then the 3D scan of the skull was sent to another scientist professionals who reconstructed the face that you can see on the screen. Is also available on National Geographic website. So this was very condensed portion of information. I know it's a lot, but I think it's important to know more or less how it works and what you have available, what tools you have available as archaeologists or museologists to work with those precious artifacts. The meeting is recorded, so you will also be getting the video, so you can go back to it and refresh the information. I will be also available for all of your questions after the webinar, and later on you will have a contact to me. So hopefully that methods of those technologies, 3D technologies, will be even more popular in the industry. And now I will give the floor to Paweł, who will show you the live demonstration of the 3D scanner and what you can do, what you will get as the results, and what you can do with it.
Great. Thank you, Natalia. Thank you for all the really detailed information. I hope you can see and hear me really clear. From my side, from my point of view, I would like to add a little bit more information about the technical stuff and everything that was connected with the technical elements, including, of course, our softwares and our devices. So let's start maybe from the beginning, from the hardware. And I would like to present our two devices, the main devices that we are using to make the digitalizations, archiving, and capturing the information about the geometry and also the color of the object. So let's start, for example, with the SMARTTECH3D. It's the smaller version of our scanners, and it also includes the stereo version. So we've got two detectors. In this case, we've got the detectors of the resolution of 5 megapixels per each of the detector, of course, and we are using the white light. It's quite important because if you would like to catch some information and gather some information about the color, we need to use the white color. That's quite important because in the white color, we've got all of the information about the red, green, and blue parameters of the color. Above of it, we've got our a little bit more advanced device, the Micron 3D color stereo device. Over there, we've got 12 megapixels of resolutions per each of the cameras, of course, both of them. It's a little bit heavy duty device, but thanks to it, we can achieve and get much more of the details onto the surface of the object. Of course, as well as on the SMARTTECH3D, we need to use the white color. So thanks to it, we are going to use also the rotary stage. And during the whole process, I would like to start with the main subject, main topic, that is the scanning of the whole object. So let's start the whole scanning process. Over here, it is really quick. So for example, if you can pay attention to the next device, it will be a little bit easier for us, because the structural light scanners, they need to make the scan thanks to the light. So we need to project the horizontal and vertical stripes exactly onto the surface of the objects, and that allows us to get the back informations exactly to the detectors. And in the end, we are grabbing those kind of the informations. If you would like to have the better quality of the whole scan and better implementations of the color, we are using also the shadeless system. That is really important in our case, because we want to remove all of the shadows from the surface of the objects that may, thanks to it, we are gathering much better and clear informations. If we would like to make the scan with the rotation, so prepare better automatizations of the whole scanning process, we can use, for example, the rotary stage. Over here is the smaller device that we can produce and we can develop. But it's not the only device that we can do. For example, if you would like to make the whole scan, of course, the result that we are achieving from this side, it's like Natalia said at the beginning of the presentations, it's the cloud of points. But the density of the points is so high that we can see all of those, let's say, details exactly onto the object. And even it's not the surface, it's not a problem for us, because we are going to transform it to the triangle mesh, the surface, in a minute. But going back a little bit to the more technical subject, all of the points that we are achieving out here, they've got their own informations about the color. Like I said, the RGB informations of the color. So that is really important, because we are doing the whole process is making a little bit more automatized, and we're grabbing the texture during the scanning process. So we don't need to make the additional like the photos just after it. So let's go to the rotate station. And for example, as an operator, I can, for example, change the range and also the step of the rotations. So for example, out here, we would like to make the scan of the different angles. Okay. So right now, I think you can hear me a little bit quicker. Let's make the scan that I made before invisible. So you are going to see the raw data from the rotary stage. During this process, we can, for example, pay attention to the whole scanning process. So basically, right now, we are making the projection, the horizontal and vertical stripes. Detectors grabbing the information from it, from the, let's say, curvature of the object, and then the laptop, actually, it might be just the single gaming laptop with a little bit better processor and the higher amount of the RAM memory. So we don't need to use the really high technology and really like the expensive processors in our devices, because our software was really automatized. So we can work with the big amount of the data with the standard devices. So going back to the scanning process, after each of the the projection of the horizontal and vertical stripes, we need to use also the shadeless system. So the whole lightning will appear in the 1 second. Then we're grabbing the information about the texture. The rotary stage will go to the next position, and then the whole process will repeat automatically. So that's how it's going to work in this moment. We are going to grab 4 of those measurements, and in a second, we are going to see the whole result. Of course, our software, like you can see, we've got the results from all of the sides, and even those 4 positions allows us to capture much more of the informations. Theoretically, as you can see on the screen, we've got some of the noises, but it's not a problem for us, because all we have to do, it's a really quick and simple options, and I think everyone, after really quick
training will be able to do it on his own. We need to go to the points and just make the post-processings. So the software algorithm inside of our software allows us to automatically calculate all of those points that are not strictly connected with the main geometry of the objects. Then as an operator, I can choose if those points that we can see out here selected on the green color, they are like the elements that we would like to remove. Let's say we can, for example, change this value to the smaller one. We can delete those points, that was noises in our case, and let's, for example, remove those points with the next method, I mean the manual method. And voila, we've got the whole object prepared with the much better condition. We can do one more thing. Of course, it's not necessary, but it will allow us to get a little bit better result. So we are grabbing all of the clouds and stick it together like using the best fit method algorithm inside of our software. So generally, what we will see out here from my side, that was the first scan that we achieved from one side. Then the rotary stage moved to the next position and the scanner grabbed another information. So we are feeling all of those objects from the many different angles. And in the end, we are grabbing this kind of the information after like 1 minute post-processing. Of course, it's another quite important thing, because if you would like to, we can transform those data into the triangle mesh. So let's do it. We can set it with the triangles, then creating, and actually that's it. We need to wait just a little bit until we will have the whole information about the triangle mesh. During this process, it might be really important, because, like I said, we are grabbing a lot of information during one time. On the bottom part of the screen, you can see that right now this project, what we can see out there on this display, it's about 3 million points. So for example, if you would like to use the, let's say, higher resolution of the scanner, for example, the Micron 3D color stereo, then with those 4 scans, we'll have much bigger amount of the cloud, like the points that we can achieve out here. And I prepared for you another thing, because what you can see is the result from the 5 megapixels of resolutions, the SMARTTECH3D on, and still we can see all of those defects, all of those parts and damages on the surface of this sculpture out here. And if you would like to see it, it's not a problem, because we can also turn the live view in our software and turn the additional lighting. So we'll see clearly how the whole software, the whole device see the whole objects. Over here, it's the selective scanning method that I used during the whole scanning process to allow us to focus only on the surface that we are interested in. So for example, if you would like to speed up the whole scanning process, you can just select the particular element in the whole sculpture that you are interested in, and it will make the whole scanning process faster. So let's come back to our object, scanned object. What we can see out here is the triangle mesh, like I said before. And if you would like to compare it with the 12 megapixels of resolutions, I prepared this kind of the project a little bit earlier. So let's come back to the next image. And as you can see out here, this is the whole informations and the surface of the object with the 12 megapixels of resolutions. You may ask why we've got so much of, let's say, the roughness on the surface. It's because, like, originally this object was made from like the rough and sandy surface. So that's why we've got much more of the details and informations onto the surface. But we are still right now talking about the geometry and the objects. But what if we would like to make the whole texturing of the objects? All we have to do is to go to the very particular toolbar and create the software, the whole texture that will be gathered from the points that we achieved before. I've got it already done, so we need to swap to the next positions, and this is the result that we achieved with the geometry and also the texture. The whole object, the whole look from all of the angles. That's how it looks like. And this is like the standard method that we are achieving because we can use 2 separate methods into the texturing the whole object. So as you can see, the angle and all of the informations, of course, the texture was added to the very particular each of the triangle that we've got out here. But it's not the end. With our devices, we can focus on the digitalizations, visualizations like you've got out here, but we can also prepare some kind of the documentations that might be really important in our case. So for example, if we'll have the information about the cloud of points out here, we can select all of those points and export the texture. Let's do it, for example, in my case on the desktop. Choose the folder. We'll have the information in a minute that all texture exported successfully, and we can come back to my desktop. The whole object will appear out here in this folder, and when we'll get into it, we'll have saved all of those photos that was used during the texturing and also grabbing the information about the object. So for example, if you would like to make like the, let's say, 3D model of the whole object, the exhibit, the sculpture, the monument, you can also prepare the whole documentations. And because we are using the stereo system, we are gathering twice as amount of the photos that we will be able to achieve with the standard single scanner. And in our case, when we are talking about the digitalizations and the good implementations of the color to the virtual reality, the bigger number of the, let's say, informations, it's really crucial, and we can prepare better texture thanks to those scans. And when we are talking about this method, lastly, we were working as a, let's say, measurement team in our office on the digitalizations in the museum in Poland. And for example, out there was a lot of sculptures that they've got really difficult geometry and also the surface, because it was covered with the paint and the surface was also glazed. So it might be a little bit difficult, but still, I hope that you will see the result out here. Unfortunately, we are still working together with the digitalizations, so I cannot show you all of the bigger amount of the informations. But as you can see on the left side, we've got the informations from the photo, just the single photo of the texture. And on the right side, you can see the triangle mesh prepared with the cloud of points, of course, and then added the texture it. So even with our new method of texturing, we can see that all of those scratches will also be visible even if the whole surface is glazed. So we are trying to improve our software all the time. Thanks to that, we've got our own software engineers in the company. We can implement a lot of extra applications and features and functions. So for example, if in the future you would like to prepare some special project, we are open to communicate with you, and we are open to hear all of your let's say things that you would like to work with us. Those are one of the most important things when we are talking about the digitalizations, archiving, and also documentations. But let's stay and just for a little bit with our objects, for example, the triangle mesh, because we are still working and we can make some measurements, even if we are talking just about the digitalizations. So to do it, all we have to do is to go to the control when we've got all sections and all of applications that we can use for just the measuring process. So for example, if you'd like to measure the distance between 2 points, it's not a problem in our case. You just need to select both of them, and in the minute we should have also the informations out here with the distance method, and over here we've got it out there. This is the value of it, but it's not a problem if you would like to also make the cross section. So all you have to do is to select our cloud of points, prepare the cross section that might be important in our case. We can do multiple amount of it. So for example, that might be the first, the second, and let's, for example, add another 2 cross sections that we can also export those data into the different softwares. So we wanted to be fully open for our customers, and if they want to just use our scanner to capture the informations, it is possible, and then they can use, for example, with the different softwares. But going back to the cross sections, with all of it, we've got a lot of information that might be really useful in the medical purposes, or like digitalization some exhibits. This is quite important. And for example, we can use the different methods to the measuring. For example, out here, if you would like to compare it with the real object, we can use the 3D distance, so like the three-dimensional measuring, so like the distance between 2 points. But if you would like to, we can also use the two-dimensional measuring that allows us to also measure, for example, the perimeter of the whole object out here. If you'd like to, we can also measure only the part that we're interested in. So all of those features are possible when you would like to use our software. And I think this is one of the most important things, that we want to use our devices in the, let's say, digitalization's purposes, but you've got also the possibility to use our measuring softwares and measuring applications. So you will have actually all of those informations in one software with our devices. And I think that will be like the most the most important informations. And if you have also some questions, we are open to it. And yeah, maybe Natalia, you've got something to add to the whole presentations, or?
Yeah, from my side, I think that it is clearly visible that the new technologies are allowing a lot of applications, giving us a lot of tools to help with the work, with the archaeological work. And now on the screen you should see the contact data to us. So if you would have any interesting projects or any questions later on, you are very welcome to contact us. We are also available on LinkedIn. Thank you so much.
Thank you.
Nice rest of the day. Thank you so much.
Yeah, that's true. Thank you, and bye.